Assalamu alaikum. Today I am going to explain product of path homotopy classes. In previous lectures we saw that how to product of paths. So we are going to explain how to product of path homotopy classes. So this is the class of path and this is the class of second path. Another path is equal to the product of first path into second path and the class of this path. We want to show that the product of paths that this class is equal to the product of first path class homotopy path homotopy class concatenation the product of second path homotopy class. So we want to show that this is equal, this both are equal. So first we take f dash is a path homotopy of f, and let's say g dash is a path homotopic to g, and g dash belongs to this class. So we define a path homotopy which of s comma t is equal to f of s to s comma t, where s belongs to 0 to half, and second path homotopy g where 2s minus 1 comma t, and s started from half and end at 1. As we know that f is the path homotopy between f and f dash, means f and f dash are two paths, so f is the path homotopy between f and f dash here, and g is the path homotopy between g and g dash. So if we substitute h of s in the place of s is equal to 0, so h for all t belongs to unit interval 0 comma 1 close interval. So if we substitute s is equal to 0, we can see that here is the point 0. So f of 0 comma t, as we know that f of 0 comma t is equal to x naught. X naught is the starting point, initial point of this path f. And if we substitute h half s is equal to half comma t for all t belongs to 0 comma t 0 comma 1 unit interval close interval. So f, if we substitute s is equal to half, so in this portion, so we can see 2 into 1 upon 2 comma t, so 2 divided by 2 is equal to 1, so f of 1 comma t, and if we know that f of 1 comma t is equal to x1 is the final point of terminal point of this path f. We substitute half s is equal to half again because half we substitute half s is equal to half again because half lies here and here also. So in for this portion we use half s is equal to half, so h of half comma t is equal to g of 2 into half minus 1 comma t for all t belongs to unit close unit interval 0 to 1, 2 divided by 2, so g of 1 minus 1 comma 0 comma t, as we know that g of 0 comma t is equal to x1 is the starting point, initial point of g graph. So g of 0 comma t for all t belongs to unit interval 0 to 1 close interval, and g of 0 comma t is equal to x1. X1 is the initial point of path g. Okay. If we substitute s is equal to 1, so h of 1 comma t for all t belongs to unit closed interval. So we can see that 2 ones are 2 minus 1, 1. So g of 1 comma t, and we know that g of 1 comma t is equal to x2. x2 is the terminal point of second path. So we can see that this is the path homotopy f I cross I. First of all, I explain the path homotopy between f and f dash. So I cross I to x, this is the path homotopy. If we substitute f of 0 comma t for all t belongs to this unit interval, so we will get x naught. X naught is the initial point of this path. So if we substitute f of s is equal to 1 comma t, so we will get x1. So x1 is the final terminal point of this path. So if we replace s comma t for all s belongs to unit interval, so if we replace t is equal to 1, if we substitute t is equal to 1, so we will get the path f of s for all s belongs to unit interval. So we can see that this is the path. Initial point is x naught and the final point is x1. This is the path. If we substitute t is equal to t is equal to 0, we will get f of s. If we substitute t is equal to 1, so we will get f dash. This is the second path. Initial point x0 and final point x1. Here t is equal to 0, at t is equal to 1, this is the path f dash. And second path homotopy is g of I cross I to x. So g of s comma is 0, so we will get g of s, and g of s comma 1 if t is equal to 1 for all s belongs to unit interval. So g dash of s for all s belongs to this. This is the path, first path, g of s, and this is the second path, g dash s. At t is equal to 0, we will get this g path, and if t substitute t is equal to 1, so we will get this path. If we change the order of s, so s is equal to 0 to t for all t belongs to unit interval, so we will get x1. x1 is the initial point of this path, both paths, and g of 0 1 comma t, if we substitute s is equal to 1 and for all t belongs to unit interval, so we will get x2. x2 is the final terminal point of both paths. So we can see that both homotopies f and g. For f, we already saw x0 to x1. This is the f path at t is equal to 0. This is the f dash path at t is equal to 1. And then according to this homotopy, at t is equal to 0 and s is equal to 0 x1 also. This is the g of 0 comma t to x1, and at t is equal to 1, we get g dash, and g of 1 comma t is equal to g of 1, and this is the g of 0. So this is x2. So according to according to homotopy, path homotopy product, we already see at previous page, h of s comma t is equal to f of 2s comma t for s belongs to 0 to half unit interval, and not unit interval. This is a interval from 0 to half, close interval. And second homotopy, 2s minus 1 comma t is Here S is belongs to starting from half to 1 close interval. So we can see that according to this homotopy at previous page. So according to this homotopy, path homotopy is the product of F concatenation G. So the product of two path homotopies f of 2s comma t, where s belongs to 0 to half, and g of s comma 2s minus 1 comma t from s starting from half to 1. So if we substitute it 0s is equal to 0, we get this f of 0 comma t. This is f of 0, and f of 0 is the starting point, initial point of this path, and h of half. So we get this, and this is the f of 1, the initial final point of this path f. And if we replace t is equal to 0, so we get this path. And if t is equal to 1, so we get f dash path. Means here I explained here. If h of 0 comma t, f of 0 comma t, this is f of 0. For s is equal to half, s is equal to 0, we get this, and this is equal to f of 0. If t is equal to 0, we get this. Sorry, we get, if t is equal to 0, f of 0 comma 0, we get f of s. F of s means initial, this is the path. And if t is equal to 0 and s is equal to 0, according to s is equal to 0, we get this x naught initial path of this path. If t is equal to 0, we get f of s. F of s means this is this path, and if 0 comma 1, t is equal to 1, so we get this second path, f dash of s. And if we replace 1, so we get this x1, and according here, so x1. If we replace t is equal to 0 to 1, we will continuously deforming the paths from f of s to f dash s. And if we substitute s is equal to, according to second path homotopy g, 0 comma half comma t, so g of 0 comma t, and if we h is s is equal to 1 comma t, so g of 1 comma t at g of 0 comma t is equal to x1 starting from here, and x1 is equal to g of 0 and g dash of 0. Means both paths g and g dash starting point is here when s is equal to 0. If t is equal to 0, we get this path, and if t is equal to 1, we get this path. At this point, s is equal to 1 for all t belongs to this, we get g of 1 or g dash of 1. This is x2, the terminal point of both paths, means this the terminal point x2. And if we replace t is equal to 0, we get g dash, and t is equal to 1, g dash. So there is a path homotopy of product of two path homotopies. H is the path homotopy of the product of two path homotopies f and f dash. At we can see that the diagram of this picture, I cross I, this is the s coordinate system, here 0 to 1, and here t is equal to 0 to 1. According to path homotopies, at s is equal to half, s is equal to half, this portion and this portion. T is equal to 0 to 1. At S is equal to half, we get the path homotopy F dash. Oh, sorry, F. F is the path homotopy in between F and F dash. This is the x naught, this is x1. X naught is f of 0 and f dash of 0 is equal to x naught, initial point of both paths. At t is equal to 1 f dash f path and t is equal to 1 f dash path. We explained here previous pages. At s is equal to half to 1, we get another homotopy, path homotopy G, and G is the path homotopy in between G and G dash. This is G, sorry, this is G and G dash. At t is equal to 0, we get this path, and t is equal to 1, we get this path. And s is equal to 0 means G of 0 and G dash of 0 is the initial point of these two paths, and at G of 0 1 comma t, for all t belongs to this, we get this point, final point of G1, G dash of 1, G of 1. And we can see that at half, S is equal to half. And we can see that if we S is equal to half, substituted f of 1 comma t and G of 0 comma t and f dash of 1 comma t is equal to f of 1 or f dash of 1. This is the final point x1, and at G of 0 comma t, for all t belongs to this, G of 0 and G of dash of 0 means both are equal and both are equal to x1. So according to this, this is related to pasting lemma. Pasting lemma, this path homotopy is well defined, h of s comma t. This is the path homotopy is well defined, and required path homotopy from x1 to x0 to x2 means here and here, this and this, and this is the classes. This is the class of this f, f1, f2 and f dash, and this is the class of g dash, g, and this is g dash, both are same class. So we can define f steric g is path homotopy to f dash steric g, means f steric multiplication product of path homotopy classes of f, concatenation of product of g is equal to f steric g. This is proof of the path homotopy, product of path homotopy. Thank you. Well.